All right, in hypothesis testing, you have two choices. You can either reject the null hypothesis, so that's the first choice, or you can fail to reject the null hypothesis, and that's the second choice. Okay, and so starting with rejecting the null hypothesis, we'll do this when the p-value is less than alpha. And remember, p-value is something that you calculate based off your data, and alpha is the acceptable type 1 error rate, or the acceptable false positive rate. Okay, so say you were to calculate your p-value, and you were to have observed a p-value of, let's say, 0.01, and then you have predetermined that your alpha is going to be 0.05, okay? And so you'd say, oh, well, 0.01 is less than 0.05, and you will be in this scenario where you are going to reject your null hypothesis. Okay, now once you've rejected your null hypothesis, you need to make a decision regarding the alternative. Okay, so what does rejecting the null mean in terms of the alternative? Okay, so if we've rejected the null, cross it out, okay? You have to accept one of these two, all right? So if we reject the null, then we must be saying, okay, you know what? There's evidence to suggest that the alternative is true, okay? So when you've rejected the null, you say there is evidence to suggest HA is true. And usually we don't write HA. Rather, we write that the population mean is more than, you write out basically what this is saying in English, in plain English. Okay? So instead of writing HA, you'd write that the population mean, which is what mu is more than 24,191. All right? All right. Second choice is you fail to reject the null hypothesis. And you will do this when you have a p-value. So say I were to have calculated my p-value based off my data, and I have 0.06. Okay, and alpha is 0.05. So 0.06 is more than 0.05. So that brings us to this fail to reject the null hypothesis scenario. All right, and when you have failed to reject the null hypothesis, you are basically saying the null is possible. It's possible that the null is true, right? We're not saying that the null is true. We're not saying that mu is 24,191, but it's possible that it is. So that's why we say we fail to reject the null hypothesis. We never accept a null hypothesis, okay? But we fail to reject it. It's possible that the null hypothesis is true, that mu equals 24,191. Now, if it's possible the null is true, that means we don't have evidence for the alternative, okay? So that is this, there is not enough evidence to suggest HA is true. And of course, we don't write HA, but rather we write out that the population mean is more than 24,191. So you write out HA in English, right? So there is not enough evidence. And the reason why we say there's not enough evidence is because, if we had a larger sample size, we may have observed this difference, between our sample mean and whatever mu is. We might have observed this difference to be larger, right, with a larger sample size. Or, the standard deviation divided by the sample standard deviation divided by the sample size. Also, with a larger sample size, this will come down. The standard error will come down, right? Which will make your, potentially could make your test statistic larger, which will make your p-value smaller. So there is not enough evidence. We never say there's no evidence, right? It's not that we don't have evidence. Like, the sample mean was larger than the 24,191. So there is, some evidence, but it's just not enough, right? It's not significantly larger, which is why we say there's not enough evidence to suggest that the population mean is more than 24,191, even though the sample mean was indeed larger than that number, okay?